this session will all be about securing your supply chain, your .NET application supply chain. If there are any people in this room who have seen talks that I've done previously on this topic, a bit of a disclaimer. I will probably show stuff that you've seen before, but the concepts do still, like, they have not changed, of course. There are a couple of new things that happen, some incidents that I'm going to talk about, and the industry has made some good progress on what we can do in order to fix it. And that's done by, let's say, Google, IBM, Microsoft. They've done some real good stuff to become better in this space. So that's a bit of a disclaimer so that you're aware of it. First, who am I? So my name is Niels Tanis, and I work as a security researcher for Veracode. I have a background in .NET development. I started out doing that with the first bits of .NET. And then I moved more to this security space where I did consultancy. I also did some ethical hacking, pen testing, which was really fun to do. But then I realized, like, building is a lot more important. Building the right software, making, let's say, no mistakes, securing your software, that's really important. So that's what I'm currently, like, combining in my role at Veracode, where I focus on static analysis of .NET applications. So it's like all coming together. So if you want to talk more about Veracode, come see me afterwards, because that's not what I'm here, like, to do a sales pitch or something. There's going to be one mention of the company, but that's you will notice it, and I will stick with that. That's it, I promise. So securing your .NET application software supply chain. If we look at the way that we are developing software nowadays, it has definitely changed compared to how I started out my own development. 2002 with .NET. At some point, the project needs to be delivered. You have an MSI, like an installation package. You hand it over to the IT guy, say, like, hey, install this on one of the machines that's accessible inside your network. And after that, like, end users, employees can access it. If we then look at it nowadays, like what's happening right now, we have cloud native, it's all much more fine-grained. We deploy maybe on a minutes basis, right, if needed. And it's not that there's one big deployment anymore. It has been a lot of small parts that will then be shared across maybe a cloud native infrastructure, which makes it a lot more complex. And also, we need to be more aware of all the moving parts coming together into our software supply chain. And there are some problems with that, and that's what we're going to cover today. So first, I want to briefly, like, create a definition of the supply chain that I'm going to stick to during this talk. More like, hey, these are the problem areas. And then we're going to talk about some examples, some supply chain hacks you probably have heard about. And then we're going to move into, hey, if we are going to secure the supply chain, we need to look at how developers interact with source. We need to look at how we deal with third-party libraries. Like, if I'm developing, I want to reuse stuff that's already there because that's efficient, right? But pulling in libraries, you're probably all aware of it, also has some security risks tied to it. So you need to be aware of that. And then, of course, we need to build and release our software, and all of that will be, of course, involved, or that's all what we need to do for our supply chain from code to release. And then at the end, there will be conclusion and Q&A. Just a bit of a recap of the first story that I told. Like, our software and the way that we're developing has changed, becoming like the first gray box, which is the monolith that contained it all. Then we moved to service orientation with SOAP, XML, bloated, big messages, some backend, maybe some front-end, backend separation. And then luckily, technology caught up that service orientation was done throughout more better stacks, like more JSON, like much more quicker. You can work with that. And then on the right-hand side, you might see, like, hey, there is a cloud native infrastructure where stuff just gets deployed, small functions, small logical containers that will execute, that will support the business, right? So from a single piece, which is probably straightforward if you look at its supply chain compared to the more complex stuff that we do nowadays. So what's the best analogy for a software supply chain? It's what happens in the automotive industry. So at some point, a car starts being built, so there's a lump of steel that will turn into a chassis, and then along the way, each step will add value to that car. So the body panels, the engine, the gearbox, everything will be added to the car, and once it's at the end of the factory plant, then it's done, and it's being given to the customer who ordered it. But across the way, parts get added, and on average, a German car manufacturer will put 10,000 parts into a car. And what even is more distinctive is that they have like almost 2,700 different suppliers for those parts that end up in that car, right? So adding value. And if we look at software, we can do the same analogy. We have source that's being developed by a developer that ends up in some kind of a source repo. In this case, it's Git. We can just replace it with everything you're using. That doesn't matter. It's agnostic. Then, of course, we need to maybe rely on third-party libraries, as I said, for development. So those will be fetched from the repos like NuGet npm, or maybe you're going to do some stuff with some Docker-based images that you use. Then stuff needs to be built. For example, GitHub Actions, Azure Pipeline, within GitLab, doesn't matter. That's a bit that will be involved. Then hopefully everybody does Q&A, and that's Q&A, of course, making sure you meet the requirements, but most of all also do the security testing you want to do, like static analysis, checking for vulnerabilities in components that you use, that kind of things. And then at some point it's done, the build will process, you will produce an artifact that will then be released, which can be, let's say, a package you release because that's the project, or it might be a Docker image that will then be run on some Kubernetes cluster somewhere in order to go to production, right? But getting from that source file that's being developed by somebody to that binary that will be deployed or that will be released, that's the whole supply chain and all the moving parts in between, and all of them have got different risks. And if we look at supply chain, what could possibly go wrong? And I think the best example you probably are aware of is something that happened to SolarWinds. So SolarWinds had one of their build servers compromised, and it was, I believe, a VM that was being reused to build their products. And it was pretty sophisticated. They were able to hack that build server. They added malicious functionality to one of the products in order to gain access to everybody's network that were using SolarWinds projects, right? So as a whole, I think if you look at what the trend is for this type of attack, security-wise, at the beginning, when hacking started out, people were just connecting machines to the internet and they were fully open. So that was easy just to get in because, hey, if you have a SQL server that's connected to the internet and there's SA with an empty password, then that's an easy way to compromise that database server, right? But people, hopefully, or companies have come a lot better in locking down infrastructures and hopefully dealing with security problems like SQL injection, cross-site skipping, fixing those issues. So what would then be a good spot to jump onto and to hack and maybe grab resources is, of course, things that run on infrastructure. So with SolarWinds, they jumped on their build, and of course, eventually the malware was deployed. I think it was released. I'm not sure like the exact figures, how much it was like used at customers, but it was a pretty sophisticated build process, and it altered the product. And that's, of course, and then eventually like you hacked in every piece of infrastructure that was using this version, right? So pretty sophisticated, a big one. The nice thing is that SolarWinds has taken the lead. Of course, they needed to fix their problems, but they have got a solution, and I'm going to walk you through towards a solution which I think is the right direction. And they have shared that last year on how they fixed this problem. So you're going to see that at the end of this presentation. Another example of a supply chain attack, software supply chain, or supply chain attack is something that happened to Kaseya, which is service providers can maybe help out with managing infrastructure. Let's say you own a garage shop, you're not interested in doing all the IT stuff yourself, but you have maybe 5 or 6 machines that need to be maintained. Then you go to some service provider that will help you. And Kaseya is a package infrastructure integrated, right? There's it again. If you look at supply chain attacks, and if somebody wants to gain something, and it's maybe a malicious actor, and that can be somebody who wants to earn money, or maybe even nation states, right? You want to focus on this. What happened with Kaseya, it turned out that one of their products had a SQL injection problem. And with that, they were able to hijack some of the instances that were like used by Kaseya's customers, right? So the service providers were using some hosted instances of this product, allowing them to then eventually hijack the supply chain by doing some crypto locking on those instances and on the data of those customers. So quite sophisticated. Once again, I think that's the trend. We need to be aware of that it's more focusing to that. And then for software, I'm a big fan of these cartoons. You probably have seen the one that is about Jimmy drop tables, the SQL injection one. I've used that one myself in a presentation, but this one was used, I think, last year. And it talks about the all-modern infrastructure. Can be replaced with the all-modern application architecture as well. It's agnostic. But then you see a whole pile of blocks. It's like being on top of each other. But somewhere underneath, there's a project that some random person in Nebraska was thanklessly maintained since 2003, right? And I think if we look at supply chain and about like the suppliers and every bits and pieces you put into your software, if there is one project that's being maintained by somebody, if you can grab hold of that one, you will make this one tumble if that block goes out, right? That's the thing. So this is a nice thing. I can literally use this in every presentation I'm doing about security, right? Because it's all about the chain, and it's all about making sure you secure it in the right way. So let's move on. Let's focus on first problem space, which is developer interacting with source. What could possibly go wrong if you interact with source? Credentials get stolen. And this is something that happened with Canonical, I think it was 2019, if I'm correct, yeah. And somebody just grabbed hold of the credentials and was able to push source to the GitHub repositories belonging to Canonical, who are of course the people behind Ubuntu. And I'm not sure, I don't think that much happened. They kept an eye on it, there was like some bogus projects created, that was it. But you can probably imagine, like I'm showing you a couple of demos which have GitHub actions at the end, and those run on Ubuntu image, right? So you can already see like this is probably valuable to attack. What can you do in order to safeguard this? Multi-factor authentication, right? So you have a username, password, and then combined with that, there's an additional factor, which in this case, I'm showing the OTP generator, which is, I think, Microsoft, the Google one, but they will do those code and that will have like a secret that will rotate, right? So if somebody grabs hold of your credentials, let's say password, username, and the person doesn't have access to this one, it cannot log in because you need to have that third factor. And that's the key, right? So ordinary credential theft can be mitigated by using multi-factor authentication, for sure. So in addition to that is, aside from doing multi-factor authentication, it's also possible to sign Git commits with a GPG public-private key pair. And the nice thing is that it will give you a nice box, green box, which says it's verified, so you can assure it's me. But aside from that, you can question, like, what's the value of this, Niels? It doesn't make sense. And I agree with you on that. But it can be a visual indicator. Like, if you do git commit signing and you force that, and maybe even do workflows based on saying, like, hey, I only do it based on commits that are signed, you can at least have some track of, like, hey, if I committed something without my git commit sign inside of it, so without me signing it, that might be an indicator of compromise, right? So you need to look into that and see, like, hey, this is an anomaly in how it normally works. Because you can probably see all the other stuff we're going to talk about with supply chains. There's no single fix. It's all about making sure that you know what has happened when in order to do the right thing, right? So I think git commits can be a good addition. This is the git commit I did this morning on the repo. So this is a nice side step. So every article I'm referencing, all the code, all the slides are on a GitHub repo, which I will, this is the one you're seeing here, of course. So there's no need to note down. The links are in the notes version. I got 2 versions of the slides in that repo, so you can look up afterwards. What else can go wrong with developers interacting with source repositories? Somebody would eventually become a malicious person, and that's exactly what these people from the University of Minnesota did. They joined, I think, one of the Linux kernel teams, and they became a contributor on that project. And they eventually then, as a project, and people were of course not happy that they did that, they committed some malicious code into the kernel, just to prove, hey, if you can gain somebody's trust, it's still possible to grab foothold of, in this case, Linux kernel, and put in stuff that's not supposed to be there. Is it really reasonable to do it? Yeah, that's questionable, but I think this shows, hey, it's all about trust, right? Similarly to if you have an open source project that's being run by people, we put a lot of trust in those people, and that can still be a thing that backfires. Another thing that we, of course, need in order to interact with sources is an IDE, and this is something that was published by the GitHub security team, and it turned out that NetBeans, which is a Java IDE, was compromised, and what it did is that with each build, it will put additional code into its artifacts, like the jar file or the IR file, whatever it created, there was additional stuff being put in. You could question, hey, why would somebody want to do this? Turns out maybe this was a pretty sophisticated targeted attack against somebody who was developing stuff, because I'm not releasing stuff from my IDE, right? Hopefully you do build pipelines, you have stuff that takes care of it, right? You should not do it from the IDE. And it's also not clear who was behind this, but it's a pretty cool write-up, and if you want to read more about that, go to that article that's in this slide. What else could go wrong? So I'm a big user of VS Code, and I use VS Code combined with JetBrains Writer. And the thing you see over here, there's a lot of information, you probably cannot see it in the back, but if you look at Electron, where VS Code is based on, Electron itself has got a dependency tree of stuff where it relies on. So Electron is the small square you see on the left-hand side, and then if you go back, that's the whole transitive tree of dependencies belonging to Electron. So if you run VS Code, you run Electron, you rely on all these packages. On the right-hand side, there's like 82 dependencies. There are 110 maintainers on these different projects. So there's 110 people touching these libraries that eventually end up in the VS Code instance that you have got running on your machine, right? So keep that in mind. And these are only the maintainers. I think it is like 1100-ish type of contributors even that touch that code. So you put a lot of trust in those people doing the right thing, and everybody's keeping an eye on it, so hopefully it can be like seen early if something bad happens. But this is something to be aware of, right? Especially with the fact that, hey, you might think one dependency, but there's always a transitive tree of dependencies, right? Similar if you do a .NET project, you add one thing that comes from NuGet, you can do a list package, you can also say, show me all the transitive ones, and then you will see there's a lot more underneath. You will also pull in, and that's important. We'll get to that later on. It's important to know what's inside your software. And of course, VS Code itself, there will be vulnerabilities found. And this is one, I think, that happened in February of this year. People, if they disclose it in the right way, even make money out of it by doing bug bounties for Microsoft. Somebody found a remote code execution exploit inside of VS Code, right? So it's always good to also update that thing. What else could go wrong with VS Code? Now I'm doing this. So this was something that was published at the beginning of last year. And it turned out that somebody, I believe there was like some kind of an automated process where nightly VS Code would look into pull requests and people could just like push stuff to that repo. And it turned out that somebody was able to maintain access, right? Access to the GitHub repos itself based on a CI/CD script that had I think it was a command injection problem inside of it. So a single spot, single failure could allow him to push stuff into VS Code and maybe even get it deployed. That didn't happen. This person also disclosed it nicely, probably made money out of it. Good thing, right? Everybody's happy. So this is stuff that might go wrong with your IDE. Be aware of that. Like it's a lot bigger, and it's good to be sensible and not too paranoid, but it's also good to be aware of what's inside, right? So talking about relying on libraries, talking about stuff you're using, right? So let's move on to libraries and the libraries that we're consuming. And this is the only additional Veracode piece I mentioned to you earlier. So on a yearly basis, we publish a report called State of Software Security, where we take some of the metrics of our customers and look into trends, do some slice and dice on those metrics. And one of the things that we saw in last year's edition is that almost 79% of the people don't update any third-party library once it gets added to their project, which is quite worrisome, right? If you create a project, there's a dependency, and you don't touch the dependency anymore, what happens with dependencies? Dependencies will have security issues that need to be updated, that need to be fixed. And this is one from March of this year related to a .NET remote code execution problem. And I think it was like a double parse that turned into a stack buffer overrun, which is like something really deep into the framework. So it's always, you need to update that, right? You also need to be aware of what's inside. We're going to touch that later on. What else happens with libraries? Attackers will hijack libraries because they have malicious intent. And UA parser is a NPM package that was used to parse user agent strings inside of, like you want to know like which user agent is being used. And somebody was able to grab credentials from the maintainer and push in some malicious stuff that was stealing secrets. And I think there was also some crypto mining input inside, like he wants to steal cryptocurrencies, right? Not crypto, that's cryptography, no cryptocurrencies. And that's what happened, right? Luckily, GitHub did respond on doing that because they, of course, are like, they own NPM. They had like forced everybody as a maintainer to at least have two-factor authentication turned on. That was the first bit, and on the right-hand side, that was December of last year, they pushed it out to everybody, right? So that's a good thing. So credential theft with that thing we saw earlier should not have happened if there was multi-factor involved, unless somebody also stole the phone, like steal the phone and move on, right? But that's less than only having that single username and password. What else could go wrong with libraries that you use? Is a concept called dependency confusion. And as the name already indicates, it's about confusion, right? So let's say you have a NuGet repository that you use internally for your organization that has your own proprietary packages that you use for your development, right? If you do some centralized stuff and maybe there's a product security team that wants to like keep an eye on what you're doing, there might be that centralized repo that makes sense. Packages are indicated, I have names that make them unique. What if somebody publishes a package to NuGet public repo with the same name? Then there might be some confusion, right? That's exactly what it refers to. So some examples, and also the person who wrote this blog post is summing up like the different ways of how he used it. Eventually also made money out of it, bug bounties, right? Good spot. It's all about this dependency confusion. And if we then look at NuGet's ecosystem, what can we do? I'm not sure if you were in the talk this morning from Claire. She also did that one 2 weeks ago. That's the one I saw. I'm not sure about this morning, but I believe she had a slide on supply chain stuff as well, reproducible builds. We're going to touch that one later on. But the key could be, if you want to have control over what type of packages are used inside your project, private repo, not sure, but let's say if you have Azure Artifacts or Artifactory or some other, like say, consolidated like platform that will deliver the packages to the build server, that of course gives you a lot more control of what ends up upstream, right? If your company has public packages with a specific name, you can also consider to register that prefix, right? If you go to NuGet, you will sometimes see that mark behind a name. That means that the prefix has been registered by somebody. So Microsoft dot is registered, so you cannot publish a package that's Microsoft dot Niels if you want to do that, right? So that at least limits the scope of doing that. And of course, if you're like really paranoid, you can also still on project level decide to lock down things. I'm not sure if that's an efficient way of doing it, but it is an alternative if you want to be that paranoid. So in this slide, there's a link to a white paper that was created by Microsoft. It's just really good on talking about all the different ways of fixing this. So you should definitely look into that one if you're interested in dealing with this problem. So third-party libraries, as I said, being a developer, lazy, reuse what's already there. Don't bump your head into the same problems that somebody else has already solved, because that's probably what's going to happen. Not invented here, like I can do it better. That's usually not true. I think it's important if you develop stuff based on libraries that you have some idea of what's the intent of the library. What do you expect of the library itself? Know what's inside, right? If you have a PDF generation library, would you expect it to also do stuff with binary formatter or deserialization of data? That's a bit of a skew, right? It doesn't need that functionality if you think about it logically, right? The other thing is that, as I said, there's always a transitive list of dependencies if you look into it, right? So you might add that package, but then if you look into the whole tree of dependencies you get with that one, there's always a lot more. And I gave a talk 2 weeks ago at NDC Porto, and that video should be online, where I talk about sandboxing.NET assemblies with exactly like doing some stuff with assembly load context and minimizing the capabilities of a library, which is a concept, but it takes care of that problem because you have more control over what's inside. But for now, what can we do? So the Open Source Security Foundation, or the OpenSSF, is a Linux Foundation project that's run, and that they're involved with a lot of security products that are also related to supply chain, which you're going to see later on. But one of the projects they have is something called security scorecards, which is some kind of a security health metric for open source. And you could, I think the analogy would be nutrition labels on food. If something contains a lot of salt, it might not be better, like maybe to take an alternative, right? So security scorecards are quite similar to that. So if we look into the GitHub repo, you'll find like the whole spec and all stuff that they look into. And eventually a package will have a score. And then based on that, they will give you a list of things where they looked into. And let's say, for example, we're going to look into Electron. We're interested in that. So this is the methodology. There's one project from Google that's called deps.dev, which is a project that consumes that data that comes from that. And they allow you to understand the dependencies, that's what they said. I first looked into this in November of last year. They were saying like NuGet packages are coming soon, which is unfortunate. It's still the same right now. Hopefully they have it sorted out and available like quickly, but right now that's not the case. But you can look into packages. And let's say we want to look into Electron, the one that we saw before with the whole transitive dependency tree. If we then open up the page and I cut and paste a bit of the information out, otherwise the screen would have been too small to show it. But then you can open up its security scorecard and you can look into it. You will see there's a score on the right-hand side, on the left-hand side, some explanation, and the score total is 5.8 out of 10, which is halfway, a bit more, right? Is it good enough? You don't know. But you can see on the right-hand side, like, hey, for example, they do not sign any release, which could be a good addition. There's no sign of any fuzzing done, like security fuzzing on the project, which is like hammering with like unstructured data and see how it behaves. But they do perform some of the other CII best practices, right? And you can collapse those and you find like which conditions they look into. But this will give you a better sense of like, hey, in what shape is this project? A project that's been stale for 3 years and has no updates, I would definitely not trust it, because like, hey, what happens? Is there any security issue fixed? Like, you would maybe perhaps expect more active maintaining, right? In order to be a more, let's say, a vibrant project. So a good spot to go to. Hopefully NuGet stuff will get in there as well. And that's a good spot to look like, hey, looking into intent of libraries and looking like, hey, does it do what I expect it to do? What else could go wrong if we have NuGet packages? What can be inside a NuGet package? You probably are aware of a concept called source generators, which was introduced with .NET 5. So this is an article that's been written by one of my teammates, Matthäus. And he looked into source generators and how you could maybe leverage it to become the next SolarWinds attack. So any project or any library can have source generators inside of it. So if you take a dependency on a NuGet package that has a source generator, that will be executed as build. So what he has shown is like, hey, you can, of course, then do some malicious stuff. ASP.NET Core has got the habit of resolving controllers by name. So if you add a file that is a controller that ends with the name controller, it will be resolved and exposed, right? So that's a possible path to follow. I think he does similar kinds of things, but he has a cool write-up, including the code, if you want to look into it, right? So this is a hypothetical example of source generators being misused. What can you do with that, right? Source generators also bring a lot of good. So this is pretty rigorously saying like, hey, I want to disable all of it, which probably won't be the way to go for you. But I think you should be selective, right? Because source generators are also there for performance reasons, generating stubs, like serialization. That's a good thing. Maybe consider like being more granular on which one you want to develop or like want to disable or not. And it would be good to have some intent, like knowing like, hey, is a source generator needed in this context? I don't know. So it's another vector that can possibly be used, right? So looking into interacting with source, dealing with libraries, what's up next? We need to at some point build our software. And a key thing that we need to have in order to secure a software supply chain is something called reproducible builds. Meaning that you grab a package from NuGet. I think maybe Claire even mentioned also this morning that the future version will have availability for checking this, but I would like to know, hey, if I grab this source file that's from that release, can I rebuild that project in exactly the same way that is inside that NuGet package? Because that's reproducibility, right? There should be no difference between that. You should be able to reproduce this, and that's a hard problem. But we need that in order to make sure like, hey, we know that this is the source that was used to build this project, so we can look into it and see what's inside. So with .NET, if we look at Roslyn v11, at that point, it started out to have some kind of determinism. I think it's pretty well sorted out right now, but given the same inputs, the compiled output will always be the same, but there might be some influences like you run stuff on a specific SDK on a build server that might have influence on how things get emitted eventually inside the assembly. That's something to be aware of. But there is a good document on the Roslyn compiler where you can find like, hey, what are these deterministic inputs? Like how can it be, what does it need in order to be doing that? So now we're going to do a quick demo and just see if you're all still awake, still with me, just to get out of the slides a bit. So let's say if we start out with a simple console app and we want to see its reproducibility. Let me quickly go to the right folder. So what we see over here, it's just a simple console app. Let me close this one. It's just a .NET new project, right? Single line console. We're going to build this one and say, okay, let's build the app. Let's now take that project and copy it. Let's say app needs to become app2 as well. And now let's say .NET build app2. What if I do a diff on binary level from these projects? So what if I just say, okay, maybe this is a bit too small. Let me zoom in for you. Let's see if it works. Hopefully it's not like giving me less space. Hold on a second. So if I then do a diff on binary level, say like just compare these files byte by byte, we see that these are like different. And why are these different? So I put in a script that will do a diff, but it will also include the strings of that DLL because that's important. That's the thing we want to see. So let's do the diff script. It will build, it will run, it will create 2 files, and it will open those in this VS Code instance. Let me close this one. So what's the difference for that matter? Turns out that, of course, the debug symbols location is included inside the compiled output. For that project, of course, the inside is exactly the same, but the PDBs are included on a different location, and that's what it refers to, right? So these files are not similar, like they're not exactly the same. Maybe technically they will execute the same hello, but internally they're different, right? So that might be a problem if you look at it. What can we do with this? And I'm just gonna quickly fix it. Let me remove the app2. Let's go to the project. So let's just for the demo take some of this and say we're gonna exclude some of the debug symbols by doing this, like nothing emitted. Now we're gonna do the same action I did before, saying I'm going to copy it again, and then let's do the diff. We should see, because we did omit, there's no like marking in this diff. Those are exactly the same binaries, right? Because we excluded this. So if you release software, that's not the way how you're gonna probably build it, right? So let's move back to the slides, because in case of continuous integration, you want to do it differently. So for .NET, there's a package called .NET Reproducible, which I think also was created by Claire, that is setting some flags on MS build level, which points out that this is a continuously integration build, which will take care of some of the things, like including the debug symbols, embed them, and it will also help out with doing any source linking, right? If you have source repos that are public, then you want to be able for people just to debug into it easily, right? Source link can help out with that. So that's the first thing you can do. And there's a second package that also helps out with isolated or hermetic builds. And what happens with that is that it will give you more control over where it gets its NuGet packages, right? If you look into my machine, there's probably a couple of locations where the NuGet stores shared stuff that it fetches, and you want to have control over where a package comes from if you build it in order to be reproducible. And that's exactly what that package does. And another good thing is that they're working on doing reproducible build validation with NuGet. And this is a design document you can find on GitHub. The link is in the slides. But it allows you to validate NuGet packages and libraries. And you can say like, hey, does the linked source code match the binaries? So is that a correlation like, hey, is this really the source code that was used to build this version of this library? And the ability to then be reproducible in build. You can grab that source, rebuild it in the same way, and then do that comparison I just showed. And that should be exactly the same. And they're also planning on maybe doing a .NET Validate CLI to help you out with verifying that. So this is really cool stuff because it gets to you pretty, like as a developer, you can easily do this if this is all in, right? So good moving forward. It's not there yet, but eventually, I'm assuming that this will be in at some point. Maybe we should ask Claire again, like if there's any roadmap on this. Moving, libraries. What else is important with software? Maybe signing packages. And of course, one disclaimer, signing a package doesn't guarantee it's safe, but it can give you some guarantees of its origin. And one of the other projects that's run by the OpenSSF is, or they're involved with it, is called Sigstore. And I don't know if you've seen it, but Sigstore wants to be the Let's Encrypt for software signing. And this is a pretty cool project. They're like having a lot of momentum right now, and this is really helping out. So what it does, there is a root CA, and it allows you to sign software artifacts. And what it does is pretty nifty. So it allows you to generate key pairs in order to sign an artifact. Then you go to their service, you get a certificate, which is only valid for 10 minutes for you to sign your package with a timestamp attached to it, right? So, and after that, the certificate will expire and will be worthless, but somebody can still validate based on the timestamp and the signing that has been done that it matches up with the CA that they also own. It's a whole ecosystem. And there's a transparency log that will point you out to like, hey, somebody with this subject, with these elements inside of it, has generated this certificate and has signed this artifact with it. That's the transparency, right? If you run Let's Encrypt, there's a couple of cool transparency logs on the internet. I would assume that your employer is keeping an eye out when domains that they own get certificates issued, because that might be a problem if that happens and you have no idea that it happens, right? It's pretty low barrier if you want to do TLS with Let's Encrypt, and this is the same what they want to do with Sigstore, and that's pretty cool. And it's free, you can just use it, right? Some bits and pieces, as I already said, there's a transparency log, there's a lot of other things involved. But one cool project on top of Sigstore, and that's also one that they released, is called Cosign. And Cosign allows you to sign Docker images. So it allows you to do that same certificate signing of an image. You can do that based on OpenID Connect as well. So there are demos, you can, if you search for it, and it's also in the links, you will see somebody sign a Docker image, and then that person will sign into, let's say, Microsoft or Google. That's an identity that will be used to put in as a subject on that signing certificate for that image, right? So that gives you some guarantee that at that point, when that Docker image got signed by, let's say, myself, I signed into Microsoft, and I'm certain that I'm the only one that has access to that system. That gives you some idea of its origin. I think that's pretty powerful, right? If that doesn't match up and something happens and it's signed, or it's signed by somebody with a different subject, then I would start worrying, because like, hey, that's not how I will use it myself, right? And the cool thing is that GitHub Actions in November last year got support for OpenID Connect. So GitHub Actions workflow can authenticate itself against other services. So you can go out to a other service and then get access to it. And Cosign also allows you to do that keyless thing if you sign in based on GitHub Actions. So this is almost like a no-brainer. You can just put it inside your build system, and then also sign that image based on the workflow that's being executed at that point. So that will give the consumers of that image some guarantee of like, hey, I can go to GitHub, I can see that workflow, I can see that at this point it's signed, this certificate. You see all the certificate details. It also does a verify inside of the build pipeline. And I'm going to show you a demo in a couple of slides, because I'm going to share a couple of things, and then at the end there's one project that uses it all, and I will show you this as well. So this is cool, and it's really low-hanging fruit. Just do it, because it's there, and it's available, free to use. So that's pretty cool. So let me see. If we look at the problem space we're in right now, we talked a lot about pinpointing stuff and fixing stuff in specific areas. But there's a bigger problem as well, because you also want to have some sense of how your product is being built. Are the steps that are taken, are those the ones that I expect? And now we're going to do one more small sidestep again and move back to the automotive industry, because they solved this problem pretty well. So I think everybody probably had a recall at some point from the dealership or some car manufacturing saying like, hey, you need to get back because there's a faulty, let's say, seatbelt, and we need to replace that part. How are they able to do that? They know exactly what's inside that car when it's built, right? They have a ledger of, hey, this ended up here. So the analogy, and this is one you've probably seen in previous presentations, let's say we're building a car and we have disc brakes that are being created from out of steel. Steel has an origin of a certain factory. Steel needs to be certified, tested, that kind of things, before it ends up in a factory to create a disc brakes out of. Those disc brakes will also be tested, will have numbers tied to it, like this is the serial numbers, it's been produced in Germany on that day for that matter. And then at the end, it will end up in that car, in the supply chain of that car, which adds up with all different parts that are identifiable. So this allows them to keep track of what's inside that car, and knowing like, hey, so we have a models that like was built in those 2 months, those have those faulty seatbelts, and we need to recall those cars back to the thing. So they have a pretty good ledger. And in order for us to keep track of what's inside the software, we need to do something exactly the same. And a concept that's used or that's introduced for doing that is something called software bill of materials, or SBOM. And for the sake of time, I'm not going to go over everything, but it describes where it comes from, who produced it. Even with software, it's also important to know some of the licensing stuff that's involved, right, from a legal perspective as well. So there's a whole list of stuff you can produce inside an SBOM. And one example of an SBOM, which is a lightweight SBOM, is something that can be produced with a project called Cyclone DX. And Cyclone DX will create an SBOM out of your dependency graph, including the transitive projects that you're using. So if you run this on a .NET project, you will have a nice overview. It will show you which projects are being used, like the packages. It will also introduce, like it will have some hashes in, you can compare. So pretty powerful. This is there. You can just grab it. There's some GitHub actions you can just pull in and generate it based on a project, and that's a file that can be valuable, right? So this won't solve your supply chain problem, but this will give you the ability to act if you know that one of the libraries that are inside your project are being compromised. So that's a good thing to do. I'm going to show you in a demo that another thing that was introduced, I think it was a month ago, about Docker. Docker also has support for something they call SBOM within the CLI itself, which is pretty neat. So there's a project called Anchor, which have one product called Sift. And Sift is able to produce an SBOM based on a Docker image and its content. And it will look into the Docker image itself, into its layers, into its file system, and it will be able to identify a .NET project. It will be able to identify different things that are inside. Pretty cool. You get that for free. It's there, and you can use it. And that's also one that I'm going to show you in the demo what's inside. So this is already, let's say, Cyclone DX is the baseline. This is even taking it further. If the Docker image is the one that you're deploying, it will give you more insights of what's inside. This is cool, and it's there free. But as I said, these are all still pinpointy solutions. I would love to have more sense of my supply chain as a whole. And there's an academia project called In-toto, which has the goal of securing integrity of software supply chains. And what In-toto does, it allows you to define a supply chain based on a lot of terminology, and this is the one, but it allows you to identify people who are involved. So there's a project owner, there's a developer, there's a releaser, that kind of thing. And each of those functionaries will be identified with a public-private key pair. And they can then sign stuff that's happening. There's a definition of a supply chain, and then materials can be input and products are output, and you can chain it all up. And I've done a demo before on In-toto, and I'm not going to do it right now because there's a video, that's a link. You can see me do stuff with a project that then gets manipulated somewhere in between, right? So it defines the software supply chain. There's a developer that deals with source code. That source code will then be signed by the developer with the In-toto stuff. It will be pushed to the GitHub repo, then the releaser picks it up, and then we'll check, or that will do the same artifact, and then at the end you can do a validate and see that in somewhere in between one of those steps, stuff gets compromised. It's a real nice project, but I can assure you this is hard to do in a bigger picture, and that's also what I think is one of the downsides of doing this with In-toto. It has potential, but it needs to be better integrated, and there are a couple of ways on how to integrate this. I'm going to show you one example. So this is my awesome web app demo, which is .NET New project, but it will have some things inside the build pipeline that I'm going to show you. So hold on. So in this, I got like two build pipelines. One of them is doing the build itself, and the other one is doing the release. So if you first look into the actions that's responsible for building, maybe I should go to the YAML itself. But what it does, yeah, let's do that. Hold on a second. I can probably do that quickly, but let's go to the file. The continuous integration itself. So what it does over here, it also takes into account In-toto, but be aware, as I said, it's pretty hard. In-toto needs keys, needs to be accessible. You need to grab them from a specific source. It's not like easy to chain it up, But in this case, what I'm doing here is it writes the key files and then it does a publish of the app itself. And this also involves In-toto, which states like, hey, right now I'm doing a publish, I'm getting these source files and I'm writing these to these output files, and please generate that artifact for me that signs off that I'm doing this. That's exactly what it does. And then the Cyclone DX will be executed and will produce an SBOM that will be then stored. Then my machine is having a hard time right now, but it also does a static analysis thing that has an output file that I'm interested in, because those are static analysis results that I want to also include. And then at the end, I will also sign those artifacts with the In-toto key of the build server, having some provenance of the fact that this happened, right? And if we then look into the release, go back, we see that we have that build that I just showed before. There's artifacts. And if we open up that one, just quickly to show you, there is a, these are like the SBOM artifacts, and there's also that whole thing that was done by Cyclone, which is like a format. It's a JSON file that has every component inside of it that's being used, all the dependencies, right? So in this case, turns out that there's also iText dependency that includes this package of this version, and there's a SHA-512 of that component, right? So that's one thing. So this is like the SBOM stuff creation, and it also has In-toto artifacts. So if you look at the other demo, you have the ability to take the layout and validate it against all the actions that this build has done, in order to see if it matches up the expectations, or if something failed and something went differently, like worked out differently. Second is the other one, and that's the CI, the continuous integration for doing that container stuff I mentioned to you. So that's the release one. And what I'm doing here is, first, this one also uses that OpenID Connect, right, in order to do signing, and it signs into my Docker repo where I want to push the image itself. Then I'm building it, then I'm signing it with cosign. That's happening here. Then I'm going to verify if that signature matches, right, if it's all went through in the right way. And then at the end, what you see here, this is the same thing that you get if you do the Docker SBOM CLI call, only this is inside the action, and it will use the anchor action associated with that, which will do exactly like generation of that SBOM. And if we then look here, I'll look into the artifacts. In this case, this is the SBOM thing. Let me open it with VS Code again. Sorry for this. But this is like similar type of SBOM you saw with Cyclone DX, only it's doing that on a much granular level, because it can look into the Docker container and look what's inside. But the same format. The funny fact is that these projects all do the same formats as In-toto does already. So it can all be integrated. Because getting back to the slides, this data is useless if we don't do anything with that, right? And Google has also introduced a standard which they called Supply Chain Levels of Software Artifacts, or SLSA, SLSA. And that's a maturity model for you to look into supply chains and to see where you can fix things. And if you look at that threat model, you probably see the analogy which I showed you when we started out the presentation, the whole build stuff, the whole build pipeline, that's already there. They do a lot of good things. And the cool thing about Google SLSA is that there's different levels, right? I'm not going to go through, but there's like, you will get better each level you go through, and the specs will explain to you what you need to do, like making sure you generate provenance. And provenance are those In-toto attestations you saw before. And the cool thing is that a month ago, they released a GitHub action that can do this, and that can do it even based on 2 levels. You can do it for a normal project on level 2, which will do similar things to what I've shown you with In-toto, which is quite tedious because you need to do it all by hand. But if you do it based on the OpenID Connect thing that I showed with the container signing, you can do it like for free, and it's there, and it will do exactly the same thing, and it will create artifacts like, hey, this is being built at this point, and the output file had this hash, and that's being signed, again, by Sigstore. So you have a correlation that was done by that build server at that point in time. So there is some guarantee of that, right? Which is pretty cool. And there's also a verifier included. I want to write this demo to have a nice, cool .NET demo that uses this, because that's quite powerful. It's less manual stuff than In-toto, and it gets us there. So let's move on. And I mentioned SolarWinds at the beginning, and I also mentioned that SolarWinds did a really good job on fixing this. So at Supply Chain SecurityCon, if I get it right, or I maybe need to swap some of the words, but that's something that happened at KubeCon last year in the US. The person that is part of the SolarWinds team and does the application security showed their way of fixing their build problem they had. And Tecton Change is something that runs on OpenShift, and it almost does the same as SLSA on GitHub Actions, but only it's already built in from the start. So each build step, Tecton has got a controller, and Tecton Change will sign each of the actions that are executed, giving you the ability to correlate the whole chain of steps that are being taken. And that's all being stored in their case, they stored it inside a document DB in order to give the developers the freedom to build their system. Based on this, they needed to do some mingling with getting this build executed, so they wrote some custom stuff themselves. He also mentioned they're going to share some of the projects. I haven't seen the bits yet being published somewhere. But how can you then use this to verify, right? Because all the SBOM attestations I just showed are being put inside the database. How can you validate that nothing happened with this build pipeline? Is create a second build pipeline next to it. And that build pipeline is their, let's say, checking build pipeline, accessible for less people, more highly maintained, and it's more secure. And what they want in order to release is that the secondary pipeline needs to produce exactly the same output. So reproducible builds, the artifacts that are being published need to match up with the first one that's being done by the developer who wants to release a version of their packages, right? This is pretty cool. And this is exactly utilizing everything I just showed you before in a really cool way. And there's a video where he explains on how they got to this. IBM has OpenShift, right? Tecton runs on top of OpenShift, their CI/CD. They also wrote a really good blog post where they have the zero trust approach on dealing with supply chain attacks and security issues. And then there's a picture, and there's a lot of information in that I can show you. But what we see here is that Tecton pipelines are building stuff, are writing those SBOM attestations to a local database. And then what they then do is they have a Kyverno, which is, I think, a controller that can decide if stuff can be released or not. They looked into their things like, hey, do all the boxes tick? Like does every condition being met before we release? They look into the SBOM. Do you do all the quality assurance? Is your security scan done? That kind of things before you release. And that gives them the ability to do that. And no, this will not prevent supply chain attacks of happening. No, this will give somebody the information they need in order to decide if something happened or not. And this is cool. This is really end-to-end, pretty cool stuff. And Google was already doing similar things in 2018 when they started out working with this. So if you run on Google Cloud, there is a service I think called binary authorization, and Graphius, the container API, is also there. So what they have is the ability to ingest all the SBOM data and all the artifacts that you produce. And then with binary authorization, you can do conditionally deployments to their cloud platform. So, hey, I want to do these checks before I release. That's pretty cool. And they were already pretty far. Keep in mind that most of the stuff that's been done from SLSA is also done by Google. So they're really moving forward. And there's another company started out which does exactly the same with people that come from Google. But I'll get to that one in a couple of slides. So an alternative on Azure would be to run a similar concept on Azure pipelines. It's not there yet, but this will be the spot if you want to do the same things like of conditionally deciding to release or not. And some of the people who were at Google, IBM, they started out a company called ChainGuard. If you look up them on Twitter or their website, they're pretty chatty about what they're doing. Those people are involved with SLSA, they work on Sigstore, they're doing all the projects, pretty cool. But they also showed their product this week, which is called ChainGuard Enforce, which almost does the same thing you saw with the IBM OpenShift solution, right? The ability to harvest data of how software is being built. They put it inside something they call the lake, evidence lake. And then you can do conditionally deployment based on policies you define. And this is all targeting Kubernetes, I believe. I have not seen the demo yet. I think it's in beta, but this is also a good step forward for that matter, right? So with 5 minutes left, I'm happy that I squeezed in all the content. Maybe it's a lot. As I said, everything is in the slides, all the links. If you look at supply chain attacks, my conclusion would be like, hey, it's not how, it's just a matter of like when it will happen. And you think you need to be aware of what's inside your supply chain, how you're using your software, and also know what you're pulling into your product. If you start out doing that cycle on the X things I showed you before, and that's the first step, good, right? That's the first step in order to become more mature in everything you're doing. And if you then want to get more to that SLSA levels, you can look into their documentation and take those next steps. Working for a security company, I need to say you need to make sure that security is not an afterthought, right? Include it inside your development process. Start out with threat modeling, do all the tools, testing you want to do in order to make sure that you're in a good shape there. And then start using those SBOM tools and try to work with the output to see if it can help you out, identifying any problems that you're facing. So with that said, I'm going to wrap up. Thank you for your time. As I said, the GitHub repo link is over here. You can reach me on my email or drop me a message on Twitter, and I'm going to be around for the next, at least tomorrow as well, right, for this conference, so let me know. Are there any questions right now? There's a lot of information. I saw my slides, it's more like 60 slides. That's too much. That's too much. But as I said, all the links should be in, and the GitHub repo, I've published it this morning, so everything is there. So thank you for your time. Enjoy the rest of the conference, and hopefully see you next time.